Welcome back, guys. Once again, we've reached Unit 3, okay? Today we're going to be dealing with atoms in the periodic table. We're starting things off right now. We're just going to be dealing with atoms. In a while, we're going to move on to periodic table and trends and stuff and kind of discuss the periodic table a little bit more in depth. But for right now, let's kind of discuss atoms again. I know you've all learned this stuff since middle school and it's probably getting old. But the structure of an atom is such that we have positive protons inside the nucleus. Okay, remember the nucleus is where all of the mass of the atom is stored. The majority of the mass is stored inside that little ball that you see filled with protons and neutrons. Okay, remember protons are positively charged, as you can see in our picture down here. They're the happy ones. The neutrons are neutral. They don't really have a positive or negative vibe going for them. Okay. And the electrons are negatively charged, okay? And the positive charges of the nucleus and the electrically negative charges of the electrons kind of help to balance each other out and hold everything together. Remember, opposites attract. So positive likes negative, they kind of like to go together, okay? So remember, positives are protons, neutrals are neutrons, electrons are negative, okay? Don't forget those three. Now we have the Bohr model of the atom. This is probably how you've seen it up to now and probably how you had to work with it in middle school. We have a centralized nucleus, as you can see, and it's surrounded by rings that contain the electrons, okay? And this would be your electron cloud, right? In this case, it's called the electron cloud. As we get on further and further into chemistry, you won't necessarily learn it this time. You'll learn that this isn't necessarily the way it works, but the 2, 8, etc. rule does hold true, okay? So keep that stuff in mind, but for right now, just think of the atom in terms of rings around a giant nucleus, okay? It's like our solar system has the sun in the middle with all the planets rotating around in different orbits on the outside. The nucleus would be our sun, and all the electrons would be the planets. Does that make sense? Okay, so Bohr once again acted and he developed this idea. It was very simple of what he thought the atom might look like. Because how can you actually get down there into microscopic levels and see exactly what an atom looks like? It's very difficult. And especially at the time that when Bohr was developing this, we couldn't do things like that. So he came up with this idea using hydrogen and helium. Okay, so it was really straightforward with these two. And the atom appeared with a centralized nucleus, once again, containing all the other things around in orbits on the outside. Okay, and as you can see, the first orbit contains 2, the second orbit contains 8. Third shell in this example contains 18. But that's not always the case, right? We know that a valence electron, the valence or the outside shell, the valence shell is the outermost shell, needs to contain 8 for an atom to be happy, okay? It's to satisfy the octet rule states that the atoms want to have a full valence shell. That means they want to have 8 electrons in the outer shell of their electrons. Okay? So now that brings us to a discussion about the electrically neutral atom, okay? Electrically neutral meaning that if all things are perfect, whenever you examine something on the periodic table, you're looking as if the atom had the exact same number of protons as electrons, okay? And that's not necessarily how it works out. Okay, sometimes they gain an extra electron or they'll lose an extra electron, and that tends to mess with the charge that's going on here with the atom, okay? And if that does happen, they become what are called ions, okay? Ions are charged atoms. So, if an atom loses an electron, that means it has 1 electron less, and that would mean that the nucleus has 1 proton more than the number of electrons. Remember that protons and electrons are always equal. So if the nucleus has 1 more proton, positive charge, than it does negative charge now, it's not balanced. So the atom would have a positive charge, and that's what's called a cation, okay? Cat has a T in it, so cations are positive, okay? Plus sign in the T, okay? Anions, okay, are negatively charged. So that would mean that if an atom took on an extra electron, it would become an anion. It would gain a negative charge, okay? So this extra negative charge would be floating around in there, and we would have 1 more negative than we would a positive charge in the nucleus. So the whole atom is essentially more negative than before, okay? Anion has an N in it for negative, okay? Anion negative, cation positive. Don't forget those two differences, okay? I'll be good to go to the periodic table next time you step in for VOD 2. Hope you guys are ready for a great unit. We'll see you next time.